Welcome back everybody. This is our second session in NEET previous year questions of chapter Moving Charges and Magnetism for class 12th. Before this video, we have made one video in this series and that video can be found on our YouTube channel's playlist section. We have also started similar series for JEE previous years. So if some of your friends are preparing for JEE or you want additional practice, then you can find that playlist also in our YouTube channel's playlist section. If you like these videos, then do press the like button, share them and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. With this, let's start today's video. And in the previous one, we completed up to, I think, question number 5. Okay, we also completed 6, 7. So we will start with question number 7 today. Let me adjust pen thickness. So here, magnetic force acting on a charged particle is negative of charge particle of this value, negative charge, in magnetic field of 2 Tesla where particle velocity is mentioned. So we have to find out magnetic force on charge particle. We know that magnetic force on a charge particle, on a moving charge particle, it is given by Q into V cross B. Here Q is the charge, so putting the value, substituting, charge is 2 into 10 raised to the power minus 6. Velocity is 2I plus 2J into 10 raised to the power 6. So 10 raised to the power 6. And magnetic field is acting in Y direction. So cross 2J as magnetic field is in Y direction. So this 10 raised to the power 6 will come out and we will have minus 2. 10 raised to the power plus 6 and minus 6 get cancelled. We have 2I cross 2J. I cross J is K. So this will be 4K plus 2J cross 2J. J cross J is 0. So plus 0. So it will be minus 8K. Or we can say 8 Newton in negative Z direction to be precise. And here we have 8 Newton in Z direction. So option A will be the right answer here. Let's move to the next one. When a charged particle moving with velocity v is subjected to magnetic field of induction B, the force on it is non-zero. This implies that. Here mentioned that we have a moving charge particle and we know that on a moving charge particle, force by magnetic field is given by Q V cross B. As it is mentioned that it is not equal to 0. It means this expression is giving us some value, and for this expression to give some value, the conditions will be, first condition, Q, V and B all should be non-zero. These all values should be non-zero. And number 2, second condition, V should be perpendicular to B. The angle between, oh sorry, we cannot actually, this is not the, we can say, minimum or essential. The essential condition is that V should not be parallel or anti-parallel to B. Means the angle between V and B should be greater than 0, theta should be greater than 0 and should be less than 180. In between any of these values, when theta is greater than 0 and theta is less than 180, we will get the some value out of cross product. Means the angle between can have any value other than 0 and 180 degrees. So option D here will be the right answer. It is not necessary to have the angle equal to 90 degree, because even if we have theta is equal to 60 degree between velocity and magnetic field, even then we will get some value of this out of this cross product. And it is mentioned that there is some force, non-zero force. It is not mentioned that that force needs to be maximum. If that force needs to be maximum, only then angle between V and B needed to be 90 degree. Moving to the next one. A very long straight wire carries current I. At the instant when charge Q at point P has a velocity V, as shown, the force on the charge. So here we can see that uh, current in the wire is in the upward direction, and this upward direction is Y, and this direction of the velocity is in X direction. So assuming the same plane here, then direction out of the screen or out of the paper will be Z direction, and using right hand screw rule we can find out direction of the magnetic field in this due to this wire. So direction of magnetic field due to this wire will be, on the left hand side the field will be coming from the back of the wire, and from the right it will be going to back of the wire. So field will be in closed loops, and it will be on the left side it will be coming from the back of the wire, and on the right side it will be going into the back of the wire. So at this point P, if we find out direction of the magnetic field will look like this at point P. Here magnetic field will be pointing into the plane of the paper, or magnetic field will be in the negative Z direction. So B at point P will be minus B node K, where B node is the value of magnetic field, and mention that velocity at P is equal to V into positive I. So let's find out the direction of the force. So Fm will be Q V cross B, and charge this charge is positive Q, so Q V is V times I, cross B is B node with negative K. So it will be Q V B node, and we have I cross negative K, or this can be written as, we have I cross negative K, this can be written as K cross I, and we know K cross I is J. So we can say magnetic force will be along Y direction, along positive Y direction. So option A will be the right answer here. Moving to the next one. A charge Q moves in a region where electric field and magnetic field both exist. Then the force on it. So it is mentioned that there are both field, and we assume that we don't know the angle between the velocity and the we don't know angle between velocity and magnetic field and velocity and electric field. So we'll be assuming they are at some angle. So force due to electric field will be Q times E, and force due to magnetic field will be Q times V cross P, and total force will be their sum. So Q E plus Q V cross B, that is option D for you. Moving to the next one. Tesla is unit of, so it is unit of both magnetic field and magnetic induction. So more appropriate answer will be magnetic field, but it is also unit of magnetic induction also. So moving to the next one. Ionized hydrogen atom and alpha particle with same momentum enters perpendicular to constant magnetic field B, ratio of their radii. So here we have ionized hydrogen atom. So we know that in case of hydrogen atom, we have a proton at center and electron revolving around it. If we ionize it, if we remove the electron, we are left with just a proton with mass equal to proton and charge is equal to 1 unit. And in alpha particle, it is ionized helium nucleus. So it has a mass equal to 4 times of the proton and charge is equal to 2 times of the proton. So we have to find out their radius when they enter in the magnetic field. We know that when a particle enters in a magnetic field, its radius is given by mv by bq, where mv is the mass, v is the velocity, b is the field, and q is the charge. And mv is also equal to momentum of the particle. So momentum by bq. Now, as mentioned that they enters with same momentum, so their momentum is same. So we can say from this relation that radius for hydrogen particle plus divided by alpha particle will be equal to ph positive by b, magnetic field will be same for every both of these, and q of h multiply momentum for alpha, magnetic field will be same, and charge for alpha. Now momentum are both same for both, magnetic field is also same for both, so ratio comes out to be charge of alpha by charge of ionized hydrogen atom. Now charge on alpha particle is twice of the charge of the alpha, so their ratio of their charge is 2:1. So option D will be the right answer here. Moving to the next one. Electron moving in circular path under the influence of transverse magnetic field, value is this one. Charge by mass ratio is given, frequency of the revolution of the electron we have to find out. Now we know that radius of a particle moving uh, in a magnetic field, radius of a particle is given by mv by qb. So using this value we can find out value of the time period. Time period will be given by the total distance covered in single orbit, in single rotation. See, in single rotation distance covered is 2 pi r by the velocity of the particle. So we need r by v, and r by v can be extracted from this relation. From this, r by v will be m by qb. Using this here, time period comes out to be 2 pi m by qb. And we have to find out frequency, and we know frequency is inverse of the time period, so it will be qb by 2 pi m. So it is charge by mass, which is given to us. Magnetic field is also given to us. Substituting all the values, we have 1 by 2 pi, so it will be 3.14 into charge by mass is 1.76 into 10 raised to power 11, and magnetic field is 3.57 into 10 raised to power minus 2. Now if we compare the values, I'm going to approximate. So what we have 1.76 into 3.57 divided by 2 into 3.14 with 10 raised to power 9, multiply 10 raised to power 9. So this whole term will give us value greater than or comparable to 1, and we have here 10 raised to power 9, and 10 raised to power 9 lies in gigahertz, and all our other options are in megahertz. So in 10 raised to power 6, but we are getting here in the order of 10 raised to power 9. So Our answer will be option A, 1 gigahertz. Moving to the next one. A proton and alpha particle both enter in a region of uniform magnetic field moving at right angle to the field. Radius of circular orbits of both of the particle is equal. So radius mentioned is equal. Kinetic energy of proton is given. Then we have to find out the energy acquired by the alpha particle. So now we know that radius mentioned is equal. So radius of proton is equal to radius of alpha particle. Now, and formula for radius is mass velocity by qp, and we have been given kinetic energy of the proton. So what we will do here, first we will transform this formula in the form of kinetic energy. And how we will do that? As we know that this is momentum, so we can write it like p by qb, and we know that mv, that is momentum, can be written as, or we can say p square is equal to m square v square. We can make it work like this, that we multiply it by half and divide by multiply by 2, divide by 2 into mv square into m, that is m square v square. So now we can further write it like that, p square is equal to 2m into half mv square, and this half mv square term is equal to kinetic energy. Or we can say, you have already discussed this relation in your 11th class syllabus, that p square is equal to twice mass into kinetic energy. And from this kinetic energy, or we can say p is equal to 2m kinetic energy under root. That's the relation we are going to use here. So we can substitute this momentum by this relation 2m into ke. So radius comes out to be under root 2m into kinetic energy. Now we are going to write kinetic energy as E divided by charge into magnetic field. So now let's compare for both. As mentioned that it is equal for both, so radius of proton will be equal to twice the mass of proton into energy of proton divided by charge of proton, and magnetic field is same for both, is equal to, for alpha, twice mass of alpha, energy of alpha divided by charge of alpha into magnetic field. So now B get cancelled, and we have to find energy acquired by the alpha particle. So squaring both of sides, what we will get? We get twice mass of proton, energy of proton by square of charge of proton is equal to twice mass alpha E alpha Q alpha square. 2 get cancelled, and we have to find E alpha. So from this we can write E alpha will be Q alpha by Qp whole square with Mp by M alpha into energy of the proton, and energy of proton is 1 MeV. Putting substitution value, charge of alpha particle is twice as compared to charge of the proton, so we have 2 by 1 whole square. Mass of proton is 1 and mass of alpha particle is 4 times into energy of proton, that is 1 MeV, and 2 square is 4, 4 get cancelled with 1 by 4, so our answer is 1 MeV. So their energy is same here. Moving to the next one. Electron moving in circular orbit of radius r makes n rotation per second. Magnetic field produced at the center has magnitude. So electron is making n rotation per second, means in a second the amount of charge flowing in the loop will be n times E. This is the amount of charge flowing in the loop in a 1 second. So we get the value of charge. Now current will be, that is delta Q by delta T, and here we are doing calculation for 1 second. So charge is Ne and time is 1. So current comes out to be Ne ampere. Now at the center of a circular, we can say circular ring or circular loop, value of magnetic field is given by mu node I by twice of its radius. So it will be mu node, value of I is Ne by twice of radius. So that is option D for us. So option D will be the right answer. Moving to the next one. So here we have a particle having a mass of 10 raised to power minus 2 kg carries a charge of 5 into 10 raised to power minus 8 coulomb. The particle is given initial horizontal velocity 10 raised to power 5 meter per second in the presence of electric field and magnetic field B. To keep the particle moving in the horizontal direction, it is necessary. So it is mentioned that particle is given horizontal velocity. So suppose let's draw our coordinates. This is x, y and z. Now it is mentioned that particle is given horizontal velocity. Suppose particle is given velocity in x direction. So velocity is equal to v node of I. And at the last, it is also mentioned that particle is moving in the same direction. So if particle is moving in the same direction, means what are the, we can say, possible scenarios here? That condition A, there must not be any forces on particle in y and z direction. As particle is continue to move in the horizontal direction, then we can say particle can have force in x direction that can either increase its velocity or decrease its velocity, but direction will stay the same. So force can be in x direction, but force cannot be in y and z direction. That's the one thing. And if force cannot be in y and z direction, what it means? That these forces y and z are the perpendicular forces. So means from this we can say, point number 1, that electric field should not be in y and z direction, because if electric field is in y direction, it will it will impart force on the particle in y direction. If electric field in z direction, then there will be force in z direction. So electric field cannot be in y and z direction. And number 2, magnetic force or magnetic field can't be in y and z direction. Why? Because we know magnetic force is given by qv cross b, and velocity is in x direction. So if magnetic field is in y or z, there will be force in z or y direction, so which is not possible as per given statement. So both electric field and magnetic field can't be in y and z direction. That is the one basic conclusion which we can draw. And second conclusion that can happen, that it is possible that these fields are in y and z direction, then they should balance their forces. Second conclusion is that if E and B are in y and z direction, then they must balance forces. Then they must balance each other. These are the two possible conditions. According to them, particle will keep on moving in the horizontal direction. So one is that electric and magnetic field both are in the x direction because they can't be in yz, so they should be in x direction only, or they must be perpendicular to each other. So now looking at option 1, B should be perpendicular to the direction of the velocity, E should be along the direction of velocity. So no, that's not possible, because if B is perpendicular to the velocity, then it will uh, uh, there will be a force acting on the object in the perpendicular to direction of velocity, and that has to be balanced by electric field, and that cannot be balanced when electric field is in the direction of the velocity. Either both are perpendicular or either both are parallel. Here only B is perpendicular, so 1 is wrong. Option 2, B and E should be along the direction of the velocity. So yes, it is possible. Option 3, B and E are mutually perpendicular and perpendicular to direction of the velocity. Yes, it is possible. And fourth option, B should be along the direction of the velocity and E should be perpendicular to it. Again, that's wrong. Either both parallel or both perpendicular. So 2 and 3 are possible. That is option C. So option C will be the right answer here. Moving to the next one. A beam of cathode rays is subjected to cross electric field E and B. The field are adjusted such that beam is not deflected. The specific charge of cathode rays is given by. Now, specific charge is E by charge by mass. So we have to find out value for charge by mass of this beam. And as mentioned, that beam is not getting deflected. If beam is not deflected, means velocity of the beam is given by ratio of electric field to magnetic field. And as these forces are balanced and this is a charged beam, so velocity acquired by the charged beam is due to electric field or electric potential. Here V is the potential, so we can say QV is equal to half mv square, and from here, as we have to find E by m, so charge by mass Q by m will be half. Small v is velocity here and capital V is the potential here, and value of small v, that is velocity, is E by b. So charge by mass will be half v into E square by b square, so E square by 2vb square. That is option D for us. Moving to the next one. Under the influence of uniform magnetic field, a charged particle moves with constant speed v in a circle of radius r. Time period of the rotation of particle. So formula for time period for particle is 2 pi m by qb. So it is independent of velocity. So depend upon velocity, that is wrong. Option A is cancelled. Depends upon r, again that is cancelled. Independent of both v and r, so here neither velocity is there and neither radius is there, so yes, this works. Depends upon both v and r, so both vr and r not here, so independent of both, so D is also cancelled. So option D will be the right answer here. Next one. A particle mass m, charge q, and kinetic energy t enters a transverse magnetic field of induction B after 3-second kinetic energy of the particle. So here it is mentioned transverse magnetic field. Now what is the meaning of transverse magnetic field? That magnetic field is perpendicular to the direction of the velocity, or angle between velocity and magnetic field is 90 degree. So if velocity and magnetic field both are at 90 degree, then we will get magnetic force. Magnetic force, as we know, that is Q V cross B, and it will be QVB, as angle between V and B is 90 degree, and it is also perpendicular to both magnetic field and velocity. Now let's find out the power, because we have to find out change in kinetic energy after 3 seconds. That what is the value of kinetic energy, that we can find out that if we know the change in amount of kinetic energy. As we know from the work energy theorem, that work done is equal to delta Ke, or change in kinetic energy. Now initial kinetic energy is T. So if we find out the work done, then we also can find out the final kinetic energy, because change in kinetic energy will be final kinetic minus initial kinetic. So final kinetic energy will be work done plus initial kinetic energy. Now we know that power is work done by time. So if we know the power and multiply it by time, then we will get the work done. And power is given by dot product of force and velocity. And here force is magnetic force. And from this relation, we know that magnetic force and velocity are perpendicular to each other, means angle between them is 90 degree. And in case of dot product, if we have angle 90 degree, then dot product is equal to 0. So power is 0 here, and if power is 0, then work done is 0. And if work done is 0, then final kinetic energy is equal to initial kinetic energy. So initial kinetic energy was T, so final will also be T. So with this, we end this video here. Again, if you find this video useful, helpful, do press the like button, share button, and subscribe button also. And if you have doubts or suggestion, you can put them in comment section. And also, if you like to support us financially, then you can scan these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. And with this, we end this video here, and we will meet in next video.